The logarithm of a power. That's our next theorem. Plus the previous two theorems, and we'll continue to use the properties to simplify logarithms. So first of all, the logarithm of a power is, let's go to the theorem worksheet, and let's take you to this property. This one's pretty cool. It says that the log of something raised to a power n can be written as, you see this n right here? It's basically saying you can bring it down in front and write it in front here of the log of x where the base is b. See this log of x where the base is b and this n? You can bring that exponent down in front, and the cool thing about this is this now will help us to solve equations where my unknown is the exponent. It's a very difficult thing to do without this concept. So I'd like to share with you that if we let u equal the log of x where the base is b, again using these, so see this right here? U is equal to the log of x where the base is b. And then we put this into exponential form, but we're trying to study this logarithm of a power. So what we're going to do is we're going to raise both sides of this equation to the n power. And so raising a power to a power right here, you're supposed to multiply. Remember, x to the second raised to the third is x to the sixth, because 2 times 3 is 6. So when raising a power to a power, we multiply. This is called the power rule, and it becomes n times the log of x. So we multiply. But let's go back here. This is b to the u times n, and this is x to the n power. Well, I'm going to take this now, and I'm going to get it back into logarithmic form. So I'm going to let this be my exponent, this be my base. So un is my exponent, and b is my base. And then this x to the n is what I'm taking the log of. But remember, way up here, I said u is equal to the log of x where the base is b. U is equal to this. See this n in front, u times n? I'm going to think of it as n times u. And then I'm going to keep going further here. So n times u, which is the log of x, where the base is b. And then finally I'm going to follow up with this statement, is equal to the log of x to the n power, where the base is b. So bottom line is whenever I have the log of something that's raised to a power, I'm bringing that power down in front right here because it's easier to work with, and it's going to be very, very helpful. So let's go back to this worksheet, and I ask you to use the theorem involving logarithm of a power and the previous two theorems to write the following problems out. So I am just asking you to take this 7 and bring it down in front and write it as a multiple. Test questions might say write as a sum, because you might have multiplication, difference, because you might have division, or multiple, which is this one right here that we're doing right now, of logs. And so you're just showing me you know how to use the theorems. So this one, I'm wanting you to put the 7 in front. So you're writing it as a multiple. 7 goes in front. So again, do number 10 on your own. And I'm wanting the -3 to be a multiple in front of the log of t, where the base is d. But check out number 11 and number 12. So those involve all the theorems. Well, this one involves the multiplication theorem and the product. This one involves the division, quotient theorem. So when you see this, and I want you to write this as sum, difference, or multiple of logarithms, I first want you to write it as an addition problem. The log of x plus the log of y to the 4th plus the log of z to the third. And sometimes I'm a little lazy and I'll put my bases in afterwards, or sometimes I forget altogether. Hopefully I won't do that. And then next, because it said also write as multiples, I would really prefer that you bring the 4 down in front, and I'd really prefer that you'd bring the 3 down in front. So now you've written those as multiples. So this would be 4 times the log of y, where the base is a. And this would be 3 times the log of z, where the base is a. And then we can't forget to bring this down in our statement as well. And now we have written this as the sum and multiple of logarithms. Likewise, number 12, we'd write it as a subtraction problem. So I'd think of it as the log of x to the 4th minus the log of, be careful please, the yz squared. You better keep together first before you turn that into an addition problem, because it's minus all of this. I meant to do this in red. So it's minus all of this. So when you go to break that out, I'm going to put a big parentheses here. All of that would be the log of y plus the log of z squared. And then you see this minus sign right here? It's got to be applied to both of those when you finish this up. And on top of it, I want the 4 to come down in front. So I want that to be the 4 times the log of x. I'll put the base of a in at the very end. So let's finish this up. So 4 times the log of x, where the base is a. This minus sign means distribute a minus 1 to each of those. So minus 1 times the log of y, where the base is a. And this has got to become a minus sign. And the 2's got to be brought in front. So 2 times the log of z, where the base is a. And now I'm done. So if you had tried to break these up quickly, you might have only had the minus sign in front of this term and not in front of this term. And it needed to be in front of both. Gets even more crazy when you see a problem like this one. I'm looking to see how many I have to go yet. Yeah, quite a few. Let's try to get through these 2 in this segment. So remember that the 4th root of something means to raise everything to the 1/4 power. So that's one way to deal with this problem. So you could write this as the log of all of this, x to the 8th, y to the 12th, a to the 3rd, z to the 5th, all of it raised to the 1/4 power. If you wanted, I want you to know, I'm not going to do it this way, but if you wanted, you could raise this power to this power. So 8 times 1/4 would be a 2. 12 times 1/4 would be a 3. 3 times 1/4 would be 3/4. And 5 times 1/4 would be 5/4. Instead, again, I can't say one way is better than the other. Instead, I'm going to bring that down in front. And I'm going to write this as 1/4 times, so all of this. And while I'm at it, I'm going to break this up into a subtraction problem. The log of x to the 8th, y to the 12th, minus the log of a to the 3rd, z to the 5th. And I'll come in and put the base of a in at the very end. Whew, so now I'm going to break these up into addition. So I'm going to write this as the log of x to the 8th plus the log of y to the 12th. Don't forget there's a 1/4 out in front. And then if you don't mind, while I'm working this piece right here and writing it as an addition problem, I'm going to apply this sign to both terms. So I'll write this minus the log of a to the 3rd minus the log of z to the 5th. Again, that's because this was the log of a to the 3rd plus the log of z to the 5th, but I had to apply this minus sign to both of those. And then finally, on top of all that, I have to bring all these exponents down in front. So the 8's got to come down here. So I've got 1/4 here, and then I have 8 times the log of x plus 12 times the log of y minus 3 times the log of a minus 5 times the log of z. Oh, geez. Now I got to distribute 1/4 times each of these terms. So the first one will be 1/4 times 8 is 2 times the log of x. 1/4 times 12 will be 3 times the log of y. 1/4 times a minus 3 would be a minus 3/4 times the log of a. And 1/4 times this 5 way over here would be a minus 5/4 times the log of z. But would you now remember that all of these had a base of a? This one in particular is unusual. They all had a base of a. I'm not doing that very well. But this one, we know from another theorem, is equal to 1. So this term right here would be just minus 3/4 times 1, but just call it 3/4, along with these other 3 terms. And I'm going to try to write it a little bit more nicely now. So this one is 3 times the log of y, where the base is a. This one is 2 times the log of x, where the base is a. This is the expanded form of this original problem using all the properties. We'll come back and practice some more.